All right, welcome to another video lesson. In this lesson, we'll cover rational exponents. Now, this is something that you have not seen before, at least not formally. So this is exponential form, and this is radical form. Okay, so these two are equivalent. So what you do is, well, let me just, before I go into the examples, don't forget when you see rational, this means it's a fraction. Okay. So on to rational exponents. So if I'm given, for example, number one, okay, when I look at example number one, don't forget in class I said when it comes to the rational, let me just copy that here. When it comes to rational, you have this in your notes. This is the index of the radical. M is the power of the radicand, and A is the radicand. Okay, so then if you look at example number one, the index in this case goes in the denominator. So this is the index. So this is n, and this is the power of 7. So that's the power, so it's a power 1. So what we need to do is we need to convert this to radical form. So to do that, we just write down the index, which is 2. Index of the radical is 2, and this is 7 to the first power, which is the same as the square root of 7. So all we did was we converted from rational form or rational exponent form to radical form. So we're going to do the same thing with the next example. So for this one, given that this is 1 over 2, then we know that this is the square root. So I'm going to transform this to say that we're multiplying the square root of 5 times the square root of 5. But again, we know that 5 times 5 is 25, and the square root of 25 is 5. So then the answer to this one is 5. What about this one? We're multiplying the square root of 2 times the square root of 18, right? Because they have the same rational power, which is 1/2, and that's the square root. So then you multiply 2 times 18, which equals 36. But then the square root of 36 is equal to 6, so then this simplifies to 6. Next example, this is the cube root. So this is the same again because the index of the radical is 3, so this is the cube root of 64. But 64 is the same as what we said we can do 4 times 4 times 4, right? So 4 times 4 is 16 times 4, 64, which means this is equal to 4. Number 4. The base is 10 again, so you're basically, this is the cube root, so you multiply 10 times 100, so you're multiplying the cube root of 10 times 100, because they're both inside of a cube root. Then this is equal to the cube root of 1000, which I know it's redundant doing this, but the point is, we know that 1000 is the same as 10 times 10 times 10, which is equal to 10, and that's the answer to that problem. So this is just to get your brain warmed up for what you're going to learn today. So next part is we're going to convert to radical form. So this is, again, this is the index. So that's the index of the radical, and this is the power, in this case, of x. Okay, so what I'm going to do is I'm going to convert it to this form. So then this is the 5th root of x to the 3rd. And I can't simplify this any further, so I am done with this problem. Number 2, the index is 2, the power is 3. So this is the same as square root of x to the 3rd. But then again, we know there are 3 x's here. We need 2 of them to be able to take one out. So what I'm going to do is I'm going to rewrite this as x square root of x. Okay, I hope you understood that because we've done this before. We have 3 of them. We have, since this is square root, we need sets of 2 or pairs of 2, or I mean 2 of the same variable to be able to take one out. So that's why we can take this one out. For now, let's assume that all variables are positive. Okay, so that's the answer to this one. What about number 3? So this 1/4 applies to the, so this is the index of the radical, which is 4. So then this is actually the 4th root of, this is the first power, which means just 3 to the first times x to the first is just fourth root of 3x. That's the answer to number 3. Number 4, now notice this one is a negative power, okay? So we have a negative power here. We can't have negative exponents, so let's bring that to the denominator. So then this is 1 over x to the 1/5. So then the index of this one is, the index is 5, so this is 1 over the 5th root of x. And I don't think I like that. Let me just write it differently. So this is the 5th root of x. And as you know, we can't have radicals in the denominator, but I'm going to just let this one slide for now, okay? So I'm just going to box it in, but understand in Algebra 2, this is not allowed. Once you get to more advanced courses, then it makes no difference. All right, what about when you have a decimal as a power? So what I am going to do is I'm going to just think about, okay, 1.4 is the same as which fraction? So this is like saying 1 times 4 over 10, right? Because you have 4 over 10 is 0.4 and you have 1. So then I'm going to multiply 10 times 1, which is 10 plus 4. That's the same as 14 over 10, which simplifies to 7 over 5. So then I'm going to rewrite this as x to the 7/5 power. So then the index of this radical is 5. So I'm going to rewrite that. So we have the 5th root of x to the 7th. Since we have a 7th as a power, we can take an x out. So then this equals x times the 5th root of x to the 2nd. Right, because we have 7 of them, we can take one out, but there's 2 left inside. Okay. All right. I'm going to pause here the video and then I'll let you guys, I'll make another video to do the next part. And thank you for watching. I'll see you in the next video.